Okay, we're recording, and oops, I didn't redo my sketchbook. That's okay. Okay, so let's do some things here. First of all, d by dx, this means take the derivative. And the derivative of x is what? I don't know what that is. What did I just do? Go away. Okay. Stupid buttons on the side of the pen. We know what that is. It's 1, right? So now let's go the opposite direction. What's the integral of 1 dx? Well, this is 1 is the same as 1 times x to the 0. And what did the rule say? Let's see, the one we don't really worry about. X to the n plus 1. 0 plus 1 is 1. Over 0 plus 1 is 1. Plus c. So the integral of 1 just becomes x. What do you think the integral of 2 becomes? Yeah, it's going to become 2x. Uh-oh, plus c, plus c. We always forget those. Integral of any constant becomes that constant times x plus c. Okay, let's do another one. That was so much fun. Let's take the derivative of 3x. Yes, that would be 3. Okay, and lo and behold, integral of 3 dx, it's going to give us 3x, the same thing. Okay, just want to remember those. Now, what's the derivative of 3x squared? Well, that would be 3 times 2 is 6x. Okay, what's the integral of 6x dx? Now we're going the opposite way. The rule with integrals is constants can be pulled outside the integral because they really don't contribute. They're just a coefficient, just like this is a coefficient, and it didn't affect the exponent we had here. But it's still there because it was multiplied into the 2 to give us the 6. So here, I'm going to write it. I like to pull constants out. Okay, just a minute. We have a cat alert. Come on, down you go. Here, say hello, Olive. Okay, down you go. Go back to the window. Okay, sorry. So 6x, let's see. This is x to the first power, so that would be 6 times x to the 1 plus 1 is 2 over 2. 6 over 2 is 3, so this will give us 3x squared plus c. Holy crap, look at that. It's the same as that. We got back to where we were again. So this is taking the derivative, and what we did was the antiderivative to get back to here, 3x. Okay? Now, let's do some that are a little more fun. I just wanted to make sure that concept is really clear of derivative and antiderivative, because anytime you take an integral of a derivative, you're always going to get the original function back. And in fact, you're going to have a homework problem where, do you remember marginal revenue? Marginal revenue was the derivative of the revenue function. So if we take the integral of the marginal revenue, that's the same as taking the integral of the revenue function, which is just going to give us back the original revenue function. Ah, you're right. Got to add that constant. Okay, so now let's do some problems. New, save, no, thank you. Okay, so let's do the integral of x squared plus x to the 7th. Now, there's a rule with integration that if you're integrating separate terms like this, I can separate these into separate integrals. That's called the separate these into separate integrals because Mark says so law. And now these are much easier to integrate, where this one may give you a little indigestion. So this will be, let's see, x squared, n is 2. 2 plus 1, what is it? Everybody say it? 3. Good. So this will give me x cubed over 3 plus x to the n plus 1 over n plus 1. N is 7. So this will be x to the 7 plus 1 over 7 plus 1. So this is x cubed over 3 plus x to the 8th over 8 plus our integration constant. And in fact, each one of these gives us an integration constant that all gets jumped together into here as one big blob. We don't know what it is. There's a way to find those, and sometimes those are very, very important. But we don't care right now. See, we did one like that. We did one, okay, let's do this one here. Integral of, what is it? X cubed plus 4x dx. Okay, everyone do this on your own. Yep, why don't you pause it and try to do this, or if you want, I'll sing. I'm not gonna sing. Okay, so I'm gonna break this up into two pieces. X cubed dx plus the integral of 4x dx. And I'm also gonna take the 4 outside the integral, just so that I can not get too confused. When you get used to this, you'll start leaving it inside. But for now, I'm going to pull it out. So x is 3. 3 plus 1 is 4. So this is x to the 4th over 4. Plus 4 times, this will be x squared over 2. So x to the 4th over 4. Plus, we can do a little simplification. 2x squared plus c. Okay? Let's do another one. We don't have to save. And let's do a big, ugly, nasty one here. Integral of x to the 7th plus 6x squared minus 3x plus the square root of x. There we go. Let's do this. So I'm going to break this up into individual ones. Now, the fact of the matter is, well, first we should rewrite this, right? Of course. X to the 7th plus 6x squared minus 3x plus x to the 1/2. And you don't really have to break it up into separate integrals. I know this one by itself is going to be x to the 8th over 8. And I know this one is going to be x cubed over 3. And I know this one is going to give me an x squared over 2, because n is 1, x to the n plus 1 over n plus 1. Now this guy, what happens here? So what's 1/2 plus 1? So that would be 1/2 plus 2 over 2, so that'd be 3 over 2. I hate these halves. So this would be x to the 3/2 over 3/2. Now you're going to encounter this a lot. Oops, plus c. So let's talk about fractions in the denominator. If I have 1 over a over b, let's say, and I want to simplify this, I could multiply it by, how can I get rid of that? Well, I can multiply the bottom by b over a, and the b's will cancel and the a's will cancel and it'll disappear. But I also have to do it in the numerator as well. So that b cancels that one, that a cancels that one, and this ends up becoming, uh-oh, what the heck was that? Can I escape? No, there, I gotta do this. Yes, no. I gotta do that, and then I gotta do that. No. That, okay, there we go. So this becomes b over a. So when you have a fraction in the denominator, that's gonna become the same thing, just flipped over. When you move it to the numerator, it's gonna flip over. So this thing, when we simplify this, x to the 8th over 8 plus, let's see, 6 over 3 is 2. 3 over 2 we can't do anything about. But this 3 over 2 is going to become a 2/3. This is going to be done a lot. So get used to it. We're going to do that a ton. Okay. I'm looking at other things in the homework. Oh yeah. So here's one. And we're going to review a little basic algebra here. 3 plus 2 over 7. We know this to be 5/7, right? But I can also take this and break it up. 3 plus 7 plus 2 over 7, right? Oops, sorry. Right? If they have the same denominator, I can separate the numerator into 2 separate fractions. I can do that anytime I want. You cannot, if it was 5 over 3 plus 4, you cannot. That's my mean face. You cannot write it as 5 over 3 plus 5 over 4. You cannot split up the denominator. You can only split up the numerator. Okay, so let's say we have the integral of x cubed minus x over x to the second. Well, this is very inconvenient because this looks like a function over a function. This kind of looks like a quotient rule or something. And there are going to be things that we can do sort of like that, but no. Because I can separate this into 2 separate functions. I can write this as x cubed over x squared minus x over x squared. And shoot, I got it the wrong way. Let me do another one. Because we can't integrate, you don't know how to integrate that one yet. So let's change it to x cubed minus x to the 5th over x squared. There we go. So this will be the integral of x cubed over x squared dx minus, because the minus is right here, integral of x to the 5th over x squared dx. Now we do a little simplification. X cubed over x squared is x. X to the 5th over x squared is x to the 3rd. Integral of x to the 1st power, n is 1, x to the n plus 1 over n plus 1. This is x squared over 2 minus n is 3, so 3 plus 1 is 4, x to the 4th over 4 plus c. This is similar to, let's see, which one was it? Homework problems. There it is, number 31. It's like number 31. And lastly, here's the last kind of example I just saw in the homework. Let's say we want to integrate 3 over cube root of x. Obviously, we're going to rewrite this. 3 over x to the 1/3. And then we're going to rewrite it further because we cannot deal with x's in denominators. So this is going to be 3 times x to the minus 1/3, right? When I move something from the denominator, an x with a power, when you move it to the numerator, its exponent changes sign. And the other way, when it goes down, it changes sign as well. We're going to tend to move things up and change the sign on their exponent. So now I'll pull the 3 out. You don't really have to, you could leave it there. So n is equal to negative 1/3. So n plus 1 is going to be negative 1/3 plus 3/3. So that'd be 2/3. So this is going to be 3 times x to the 2/3 over 2/3 And 2/3 will flip and become 3/2. So this is 9/2 x to the 2/3 plus c. Does that make sense? So look at the examples in the book. There's a lot of nice examples in there. If you have any trouble, you can catch me on office hours for this. That's all of 12.1. Have fun. Bye. Stop.